Good day, STEM students. Welcome back to Mampaisan's online classroom. Today, we're going to start our discussion about Newton's law of universal gravitation. This lesson is under Module 9, wherein the Module 9 is divided into three video parts. The first one would be about the Newton's law of universal gravitation part 1, and then we have a part 2 for that. And then the last video will be all about Kepler's law of planetary motion. Here are the general objectives of Module 9. State Newton's law of universal gravitation. Use Newton's law of gravitation to infer gravitational force, weight, and acceleration due to gravity. Calculate quantities related to planetary or satellite motion. Enumerate and state Kepler's law of planetary motion. For circular orbits, relate Kepler's law of planetary motion to Newton's law of gravitation and centripetal acceleration. And lastly, cite some importance of space explorations. As an overview, this discussion about Newton's law of universal gravitation is divided into the following subtopics. First is the Newton's law of universal gravitation. Next will be acceleration due to gravity on different planets. Next, escape velocity. And then importance of space exploration. Let's start with the first part. According to Newton's law of gravitation, or the other term for it is Newton's law of universal gravitation, there is a gravitational attraction between any two objects. If the objects are point masses, m sub 1 and m sub 2, separated by a distance r, the magnitude of the force is directly proportional to the masses and inversely proportional to the square of the distance between them. Therefore, anything that has mass actually attracts each other, just like the one shown here. Let's use the pen. This one, mass 1, is attracted to mass 2 the same way that mass 2 is attracted to mass 1. And then in equation form, that is F subscript grav for gravity or gravitational, to denote that it is gravitational force, is equal to G M1 M2 over R squared. Kasi nga sabi, directly proportional to the masses yung ating gravitational force. Tapos inversely proportional to the square of the distance between them. That's why we find the R here in the denominator, and it's not just inverse proportion but it's inverse square proportion. That's why you will also see the square in the denominator. Later we will know what each of the variable represent. Ito siya. The F with the subscript GRAV or grav stands for the gravitational force in Newton, of course. Again, I will repeat, kahit anong klaseng force yan, the standard unit will always be Newton. And then the capital letter G is the universal gravitational constant. When we say universal, the constant is applicable wherever you are in the universe. So for example, you decided to go to Mars because you get tired of living here on Earth. The universal gravitational constant in Mars is the same as the universal gravitational constant here on Earth, and it is equivalent to 6.67 times 10 raised to negative 11 Newton meters squared per kilogram squared. And then the M1 and the M2, the M1 will be the mass of object 1 expressed in kilograms always, and then the m sub 2 is the mass of object 2 in kilograms. Remember, when we say object, it is synonymous to particle. So when the problem involves particles, pwede yung maging mass of the particle, no? We are not limited to macroscopic objects. This is also applicable to microscopic objects as long as they have masses. And then the r is the distance between the objects, and again, it is expressed in meters. The gravitational force is always attractive. Alam naman natin that when things fall towards the ground, it's because the ground is attracting that object towards it, or the earth itself is attracting that object towards itself. So si gravitational force, lagi siyang nang a-attract. Okay? Every mass attracts every other mass. O, huwag mo nang i-apply sa love life mo kung bakit hindi siya na-attract sa'yo, no? Ayan. Iba yon. Okay? Iba yung romantic attraction sa gravitational attraction. Magtigil ka. Next, the gravitational force is symmetric. Anong ibig sabihin nun? The magnitude of the gravitational force exerted by mass 1 on mass 2 is equal in magnitude to the force exerted by mass 2 on mass 1. So dito walang taken for granted. Whatever is exerted by mass number 1 is the same force exerted by mass number 2. Meaning, whatever is exerted by mass number 1, yun din yung kanyang nare-receive back na force. And these two forces form an action-reaction pair. And this is through neglecting the effects of other objects to the two objects na pinag-uusapan natin. Ayan. So what's the role of the law of gravitation in physics? It allows us to calculate and understand the motion of a wide variety of objects, not just objects here on Earth, but also objects outside the Earth. Newton's application of his law of gravitation to motion of planets and moons was the first time physics was successfully applied to describe the motion of the solar system. Noong unang panahon, they are not so busy trying to explain the motion of the solar system. Ang focus nila, paano nakakaapekto yung movement sa buhay ng mga tao dito sa Earth. Kapag nandyan si Venus sa quadrant na to, ito ang mangyayari. Kapag pinanganak ka na, nandito si Mars sa quadrant na to, ayan ang magiging kapalaran mo, ganun. Ayan. So, si Newton, the law of gravitation is one of the first steps to coming out of that notion na kailangan lang nating pag-aralan yung heavenly bodies kasi directly naaapektuhan nila yung ating kapalaran. Okay? Dito, it's the sole purpose of knowing how they behave, not how their behavior is affecting humans. And then, it showed that laws of physics apply to all objects. Again, it shows na yung mga alam natin sa physics is not only applicable here on Earth, pero pwede rin pala siya sa labas ng Earth. Okay? And it had an effect on how people viewed the universe. So dati nga, ang view ng tao sa universe, the universe conspire para buuin ang kapalaran ng mga tao. And since ito na yung mga revolution ng mga ideas na pinasimulan ni Newton, nag-iba na yung pananaw ng mga tao na aside or kesa alamin natin kung paano tayo maaapektuhan ng stars, bakit hindi natin alamin kung paano natin maaapektuhan sila, okay? At kung paano nila naaapektuhan ang isa't isa. Ayan. So let's have sample problem 1 about Newton's law of universal gravitation. It says here, a 50 kilogram person and a 75 kilogram person are sitting on a bench. Estimate the magnitude of the gravitational force each exerts on the other if they are 0.5 meters apart. Ayan sila, boy and girl. Tingnan natin kung gaano kalakas ang gravitational attraction nila sa isa't isa. So we have the given mass number 1, 50 kilograms. So interchangeable to, no? Kahit yung mass number 2 mo ginawa mong 50, tapos yung mass number 1 mo 75, it doesn't matter, no? Kasi multiply mo naman sila. And then, don't forget to include the universal gravitational constant, 6.67 times 10 raised to negative 11 Newton meters squared per kilogram squared. And then the distance between them, r, is equal to 0.5 meters. We are required to look for the gravitational force between these two masses. And then, of course, our equation would be F subscript grav is equal to gm1m2 over r squared. Substituting everything, we would get 1.0005 times 10 raised to negative 6 Newton. Ayan. So in scientific notation, ayan, 1 times 10 raised to negative 6 newtons. Ganyan kaliit ang attraction ng isang 50 kilogram person sa isang 75 kilogram person kahit 0.5 meters apart lang sila. In short, wag mo nang isipin na nakakaapekto ang gravitational attraction sa attraction ninyo sa isa't isa. Okay, sample problem number 2. Find the magnitude of the net force on the moon. So, yung kanina nating example is here on Earth. So, labas naman tayo sa Earth, no? Yan, the magnitude of the net force on the moon with mass 7.35 times 10 raised to 22 kilogram due to the gravitational attraction of both the Earth and the Sun, given yung mga masses nila, assuming that they are at right angles to each other. The Earth is 3.84 times 10 raised to 8 meters from the moon, and the Sun is 1.5 times 10 raised to 11 meters from the moon. So here's the illustration, assuming nga na, syempre dumadating naman talaga sa point na at right angle si Sun tsaka sa Earth kay Moon, no? Ayan. So let's have the given, the mass. So, meron tayong tatlong mass dito, no? So, pwede tayong gumamit ng mass 1, 2, 3. Pero, naisip ko na lang is to use the starting letters of the objects involved, the moon, the earth, and the sun. That's why we have M with subscript M for the mass of the moon, 7.35 times 10 raised to 22 kilograms. And then we have M sub E. The E stands for Earth, so we have its mass 5.98 times 10 raised to 24 kilograms. And then for the mass of the Sun, that's M sub S, 1.99 times 10 raised to 30 kilograms. And then don't forget again to write the universal gravitational constant. And notice na dalawa rin yung R dito kasi dalawang gravitational force yung pinag-uusapan natin. Palitan ko lang ang aking kulay ng pen. Ayan. So we have REM to denote that it is the distance between the Earth and the Moon, and then we have RSM to denote that it is the distance from the Sun to the Moon. Okay, so the distance from the distance between Earth and Moon is 3.84 times 10 raised to 8 meters, and then the distance between Sun and Moon is 1.5 times 10 raised to 11 meters. So we are again required to get the net gravitational force. That's why here you see that we have the Greek letter sigma again. So force to, syempre pwede natin itong i-add. Meaning, for example, may isang bagay, halimbawa tatlo kayo sa classroom, si classmate 1, may gravitational attraction siya kay classmate 2, tapos si classmate 3, may gravitational force din siyang ina-exert kay classmate 2. So, kung gusto mo malaman yung total na force na na-experience ni classmate 2, dapat alamin mo muna yung force between classmate 1 and 2. Tapos, next naman is yung force between classmate 2 and 3. Tapos, i-add mo yun together. Okay? That's the principle in knowing or adding the forces. Parang, ano nga, diba? How we add vectors. Okay? Next, let's have the equation. Remember, it is forming right angle, sabi, di ba? Naka-right angle daw sila. Si Sun at right angle with the moon and the Earth, kanina sa illustration natin. So, if the vectors or the forces are forming right triangle, remember that we need to use the Pythagorean equation. Okay? That's why our equation would look like this. So, meron tayong tatlong solution dito kasi kukunin natin yung FEM, which is the force between Earth and Moon, saka yung FSM, which is the gravitational force between Sun and Moon. So, that's solution number 1. We need to get the force, gravitational force between Earth and Moon, and we're going to use ME and MM. And then for the R, that's going to be the REM or the distance from between Earth and Moon. And then if we substitute, we would be able to get the answer 1.99 times 10 raised to 20 newtons. And then next, so nakuha na natin tong FEM natin. Our next goal should be to get the FSM. To get the FSM, we're going to use MS, the mass of the sun, and of course, the mass of the moon. Therefore, itong masses na to, they are the masses of the interacting bodies. And then the RSM, instead of the REN, because we're already talking about the sun and the moon. Substituting everything, we would get 4.34 times 10 raised to 20 newtons. And then lastly, we're going to get na the um, final solution, which is the net gravitational force, wherein we substitute the FEM and the FSM. And then the final answer would be 4.77 times 10 raised to 20 newtons. Now, we know that force is a vector quantity. So, ang final answer dapat natin dito, merong angle, saka merong direction. So, bakit wala siyang um, uh, hindi na natin sinolt yung angle. Remember sa vector, 'di ba, kapag nag-form sila ng right angle or ng right triangle, kunin pa natin yung inverse tangent para makuha yung angle. Tapos, i-analyze pa natin kung nasaang quadrant siya, anong direction siya. Tapos dito, wala. Bakit? Kasi ang tinatanong lang ay magnitude. Okay? So be careful of that, no? So huwag mo nang pahirapan yung sarili mo. If the problem is just asking for magnitude, you don't need to do the extra mile to get the angle as well as the direction. Ayan. So let's proceed with the gravitational force between the sun and the other planets. Yung example natin kanina, that's between the sun and the specific satellite of a specific planet, and then the planet and the satellite itself. Remember, there are natural satellites which are the moons, no? Ayan. E paano naman kapag ang i-compute mo ay gravitational force between the sun and the other planets? This table will be of help to us, and we have to take note of the following information: the mean orbital radius and the mass of the planet. Okay? Ito nakalagay dito. Baka kasing substitute na lang yung mga nakasulat dito, ha? Hindi. Dapat isasama mo yung times 10 raised to 24. Ay, ano na, yellow pala siya. Gawin natin red para mas vivid. Ayan. Tapos ito, you have to include it. Meaning, if you're going to input it in the given, or to write it as a given, it should be the mass of Venus should be 1.08 times 10. Mass tuloy, mean orbital radius of Venus would be 1.08 times 10 raised to 11 meters. Okay, yun yung ibig sabihin nung may nakalagay na times 10 raised to 11 meters dito sa taas. Tapos sa mass naman, Venus ulit, it should be 4.87 times 10 raised to 24 kilograms. Okay, don't forget to include this kasi mamamali ka. 4.87 kilograms ang yung Venus. Mas mabigat ka ba sa Venus? Yung totoo. Ayan. So for approximately circular orbits, the mean orbital radius is the distance from an object in space to the body which it is orbiting. Okay, kaya gagamitin natin to know the gravitational force between the sun and other planets. We're going to use the mean orbital radius and not the radius of object. Okay, may dalawa kasi tayong radius dito. We're going to use the mean orbital radius because that's the distance from the object in space, specifically the planets, from the object it is orbiting. Saan ba nag-orbit ng mga planets natin, di ba, sa sun? Okay? Therefore, to get the gravitational force between the sun and other planets, we can use this general equation wherein ms is the mass of the sun in kilograms, mp is the mass of the planet in kilograms, and r mean is the mean orbital radius. Later, you will know why we need to differentiate kasi meron pang isang equation for this. Okay? Ayan. Don't forget, ha, that's mean orbital radius ang gagamitin. Tapos mp, syempre kung anong planet yung pinag-uusapan. Now let's proceed to the acceleration due to gravity on different planets. Now we have already discussed the acceleration due to gravity here on Earth, simply 9.8 meters per second squared. And sinabi ko nga kapag dito sa Earth, constant siya na yun yung value niya. Pero kapag umalis ka ng Earth, lumabas ka ng Earth, you go to the outer space, the value of the acceleration due to gravity changes. So that's the difference between the big G and the small g. Kasi si big G, kahit saan ka pumunta, it's the same. 6.67 times 10 raised to negative 11 Newton meter squared per kilogram squared. Pero si G, 9.8 meter per second squared lang siya sa Earth. Pag pumunta ka sa ibang lugar, nag-iiba siya. And let's see how it changes. Ayan, let's go back here again and then let's have the gravitational force between a planet and an object on its surface naman. Okay, kasi meron ding gravitational attraction ang isang bagay na nasa surface ng isang planeta at yung planeta mismo. Okay, here, instead of using the mean orbital radius, we're going to use the radius of the object and syempre yung mass pa rin ng planeta. Okay? Yan sabi ko kanina, kailangan natin i-differentiate. What is the radius of object or planet? It's the distance from a planet's center of mass to its surface. And we know, syempre, na yung center of mass ng isang planeta, although hindi talaga siya circular in shape, it's oblate spheroid, we assume approximately na spherical siya. So, ang distance from the center of mass towards the surface, that's the radius of the object or the radius of the planet. So our equation for getting the gravitational force between a planet and an object on its surface would look like this, wherein instead of the mass of the sun and the mass of the planet, we have MO and then MP and then RP. Ano ibig sabihin yan? MO is the mass of the object in kilograms, the MP is the mass of the planet in kilograms pa rin, and then RP is the radius of the planet. Notice, kaya naging MOMP kasi this time, ang ina-analyze na natin yung interaction is the object on the surface and the planet itself. Okay, yung kanina, yung equation natin na MSMP, ang nag-interact naman doon is yung sun and yung planet. Okay? Ayan, so let's analyze this situation, the gravitational attraction and its relation to weight on Earth. Dito muna tayo sa Earth, no? Assuming spherical Earth, we can consider all the mass of the Earth to be concentrated at its center or its center of mass. The value of R in the law of gravitation is just the radius of the Earth, just like what we have shown in the equation from the previous slide. So here, let's solve for the gravitational force as well as the weight of this person standing on the surface of the Earth. Ayan. So ano mga kailangan natin given dito? The mass of the object. Let's say that the object is the man and he is 50 kilograms. And then the mass of the planet, that's Earth. Galing sa table, kinuha ko to 5.98 times 10 raised to 24 kilograms. And then syempre wag natin kakalimutan ang big G. Kailangan din natin yung small g pala. That is equal to 9.8 meter per second squared. And then the RP, which is the distance of the person from the center of the Earth. Since ang radius ng Earth is 6.37 times 10 raised to 6 meters, yan yung ating R sub P. And then what we're going to look for is the gravitational attraction or gravitational force between the Earth and the man, as well as the man's weight. For the equation, we have F grav is equal to GMOMP all over RP squared. And then for the weight, that's MO times G, wherein MO, again, is the mass of the person or the mass of the object on the surface of the Earth. Let's substitute. Solution number 1, getting the F grav. We substitute everything and then we get 491.49 newtons. And then for solution number 2, we get the weight. That's 50 times 9.8. and then we get 490 newtons. These are just magnitudes. That's why there is no negative for the 9.8. If we compare them for 91.49 newtons and weight that is 490 newtons, the percent difference between the gravitational force or the gravitational attraction and weight of the 50 kilogram man is just 0.3%. Very little, which gives us the idea that F grav is approximately equal to weight. Okay, so ibig sabihin may kinalaman si law of universal gravitation sa equation natin for weight. Okay? Now we know, we have established that approximately F grav is equal to weight. Therefore, GMOMP over RP squared is also equal to MO times G. Kasi di ba F grav surface to ng Earth, ha? Tapos object sa surface ng Earth. Ito yung equation niya. Palitan ulit natin kasi naka-red siya. Gawin natin yellow. Ayan. Ito yung para sa ating F-graph. Tapos yung weight naman, ito yung equation niya. Okay? Here, we would be able to derive the equation for acceleration due to gravity. Ayan. So, we cross-multiply. Kaya napunta na dito yung RP. Cross-multiply. Our goal, again, is to get an equation for acceleration due to gravity. So to isolate the G, or the acceleration due to gravity, on the right side of the equation, we divide both sides by MO and RP squared. Ayan. So we can cancel this. And then we are left with, ito pa, makakancel din yung MO. So we are left with the equation G is equal to MP over RP squared, which tells us that generally for us to be able to know the acceleration due to gravity of a specific planet, we just have to multiply the universal gravitational constant by the mass of the planet and divide it by the radius of the planet squared. Again, to get the acceleration due to gravity of a planet, the process would be you have to multiply the universal gravitational constant by the mass of the planet and divide it by the radius squared of that planet. So here, you would be able to get the acceleration due to gravity of Mercury, of Venus, of Mars, of Jupiter, of Saturn, of Neptune, and Uranus. Siyempre, hindi pa official na nakabalik si Pluto. So on your own, using the G is equal to Gm sub T over Rp squared, kindly solve for the acceleration due to gravity of the following planets. By the way, kapag mas malaki yung acceleration due to gravity ng isang planet, mas mahirap mag-escape sa kanyang gravitational force. Meaning, halimbawa, si Mercury, ayan, ang mass ni Mercury ay 0.33. Siya yung pinakamagaan. Tama ba ako? Yes. Sa solar system, huwag natin isama si Pluto. Yan. Siya yung pinakamagaan. Ibig sabihin, sa kanya pinaka-light ang pakiramdam natin. Lesser yung weight natin. Parating lumulutang. Ganun. Okay. Tapos kapag pumunta ka naman sa Jupiter, although hindi ka makakalakad sa Jupiter kasi gaseous planet siya, imaginein mo na lang na pwede kang may maapakan na surface doon. If ever, you'll feel heavier. Para mas mahirap kumilos, mas mahirap iangat yung paa mo because you are greatly attracted towards the planet because of its mass. Meaning, mas mahirap escape ang gravitational field or gravitational attraction mo kapag mas massive yung planet kung saan nakaapak ka, kung may surface man siya, no? Ayan. Thank you for listening to the part 1 of Newton's Law of Universal Gravitation. See you on Newton's Law of Universal Gravitation part